Okay friends, once again welcome to our new session of maths. This is standard 9 and you are learning second chapter polynomial. So from today we are going to start new chapter, that is namely polynomial. Okay. You have studied algebraic expressions, their addition, subtraction, multiplication, division in earlier standard. Means in 6, 7, 8. In earlier standard, you have studied algebraic expressions, addition of algebraic expressions, subtraction, multiplication, and division of algebraic expressions. Now you have also learned to factorize some algebraic expressions using identities like this. So you have learned to factorize the algebraic expressions using this type of identities. X plus y the whole square is equal to x square plus 2xy plus y square. If there is a negative sign between the two and a square over it, x minus y the whole square. So this is the expanded form of this identity, x square minus 2xy plus y square. You might also have used x square minus y square is equal to x plus y and x minus y. Now in this chapter, so this is for the earlier standard you have learned. So in this chapter we shall study a particular type of algebraic expressions called polynomial. Okay, so polynomial is the name of the chapter. In this chapter we are going to study a particular type of algebraic expression which is called polynomial. Now what is that? What is to learn? So the topics to learn in this chapter is polynomial and terminology related to it. There are some terminologies for related to polynomial. Okay. Then remainder theorem and factor theorem. Two types of theorems which are important to learn and their use in the factorization of polynomial. So while factorization of polynomial, these two theorems, remainder theorem and factor theorem, are very useful. Okay. And the point, the some algebraic identities and their use in the factorization of polynomial. So you have learned few identities in earlier standard, but here there are more number of identities you have to learn in this chapter, and these identities are very useful in algebra, which is a stream of mathematics. So this is the chapter, the polynomial is the chapter related to algebra, one of the branch of mathematics. And algebra, in these identities, algebraic identities are very useful. However you learn mathematics, however long you learn algebra, it is at the base. So you will learn some algebraic identities and use in factorization of polynomials. Okay. Now the first point we start, that is polynomial and its terminology. Okay. X plus 2, x square, 5 by 2 x square plus 3x minus 2, root 2x square plus 5x minus 3 are examples of polynomial in one word. So these are the examples of polynomial, rather these are the polynomials that we are going to learn about it. Okay, see x plus 2, there is a positive sign between the two. These two are known as terms. So two terms are there. In this polynomial, only one term is there. So you will learn this terminology here. Okay, see terms of polynomial. terminology. Sorry, terms. See, x square plus 2x minus 3. X square is one term, 2x is one more term, and minus 3 is another term. So x square, 2x, and minus 3 are three terms of polynomial. So this polynomial is having three terms: 1, 2, and minus 3. Means what? Terms are separated by plus or minus sign. Whenever you see plus or minus sign, these they are different terms. Look at it. This polynomial have two terms. This one have only one term. 1, 2, 3. This polynomial have three terms. 1, 2, 3. These polynomials have also three terms. So there can be only one term, there can be two terms, there can be three terms, there can be four terms, there can be infinitely many number of terms. Okay. Now coefficients of polynomial. These are the terminology. Terms of polynomial is a terminology. Coefficient of polynomial, that is also a terminology. Okay. Now coefficients of polynomial. Which are coefficients? Look at it. 3x square plus 2x minus 5 is a polynomial in one variable. One variable. Only x is there. No y, no z, no a, no b. Only x is there. So different powers, but only one variable x is there, and that is why this is the polynomial in one variable. Okay. So you are going to learn in this chapter, we have to learn polynomial in one variable. Okay, 3x square plus 2x minus 5. This is our polynomial in one variable. Now 3 is the coefficient of x square. 3 is the coefficient of x square. So coefficient is a number, it's a constant one, which is a multiple of a variable in every term. So 2 is the coefficient of x. Okay, and minus 5 is the constant. So without x, there is no x, then the number alone is known as a constant term. So 3 is the multiple of, means coefficient of x square, 2 is the coefficient of x, and minus 5 is the coefficient of, is a constant term rather. So these three are the coefficients of this particular polynomial. Okay. Now degree of polynomial. See, 2x plus 1 is a 1 degree polynomial. 2x plus 1 is a 1 degree polynomial. Why? So the maximum power of the variable is 1. Okay. Now x square plus 2x plus 1 is a 2 degree polynomial. It's a 2 degree polynomial because the maximum power of a variable is 2. See, this x square has 2 powers. This term x have 1 power, and here no x. So it's a 0 power to x. Whenever you see a constant term, there is a 0 power to the variable. Okay, so 2 powers, 1 power, 0 power. So the maximum power of variable is 2, and that is why this one is a 2 degree polynomial. Look at it. X cube minus 8 is a 3 degree polynomial. So and on. There can be a 4 degree polynomial, 5 degree polynomial, 6 degree polynomial. There can be infinite number of degree for a polynomial. Okay. So in general, the highest power of a variable is the degree of that polynomial. Okay. Now types of polynomial. Important one. See, there can be linear polynomial. Look at it. 2x, 3x minus 2, root 2x plus 5. These are all the examples of linear polynomial. See, only 1 degree polynomial. So all the 1 degree polynomials are linear polynomial. The highest power of variable in the polynomial is 1. That is, they are 1 degree polynomial, and the 1 degree polynomial are known as linear polynomial. Now look at the general form. General form is ax plus b. Okay, so we can say that a linear polynomial can have at most 2 terms. ज़्यादा से ज़्यादा 2 टर्म हो सकते हैं. ये दो टर्म वाली पॉलिनोमियल हो सकती है या एक टर्म वाली पॉलिनोमियल हो सकती है. Okay. Now quadratic polynomial. X square plus 2x plus 1, x square minus 4 minus 4x square. See, quadratic. 1 term, 2 term, 3 term. But the important thing is that the maximum power of variable is 2 in each case, and that is why it is known as quadratic polynomial. So the degree of polynomial is 2, and there can be maximum 3 terms. The general form is ax square plus bx plus c. So one term of having x square, one term with x, and one constant term. So there can be at most 3 terms. This is in the standard form, 3 terms. Okay, here one term is missing, here 2 terms are missing, but all these are the examples of quadratic polynomial. Okay, now cubic polynomial. Cubic, 3 degree polynomials. Okay. So the maximum power of the variable is 3, and that is why the polynomial is known as cubic polynomial. Minus 7x cube, x cube minus 8, x square plus 3x square plus 3x plus 1, x cube minus 8x plus 4. See, 3 degree polynomials, and the general form is ax cube, one term with x cube, one term with x square, one term with x, and one common term. These are the maximum number of terms. This can be the maximum number of terms. 4 terms can be the maximum number of terms. Here x cube plus 3x square plus 3x plus 1. Okay, so it can be 1 term polynomial, it can be 2 term polynomial, it can be 4 term polynomial, it can be 3 term. So the number of terms can be 1 or 2 or 3 or 4. It doesn't matter for a polynomial being a cubic polynomial. But the important thing is that it must have at most 3. Maximum power of the variable must be 3, not more than that, not less than that. Okay. Here, these are the constant terms. So no x here, no x here. Only numbers. 3 is a polynomial, minus 5 is a polynomial, root 7 is a polynomial, minus 25 is a polynomial. So these all are the examples of polynomial. See, the degree of the polynomial is 0. No x here, so it's x raised to 0 here. So the degree of constant polynomial is 0. You can write the general formula is equal to a. Okay, and now 0 polynomial. 0 itself is a 0 polynomial. So 0 is a number, one type of number. It can also be considered a constant polynomial, but 0 is known as a 0 polynomial. Special case. So it has no degree, my friend. Keep this thing in mind. Except 0, all the numbers are also constant polynomial. They are known as constant polynomial, and its degree is 0. But 0 has no degree at all. 0 polynomial, which is 0, has no degree at polynomial, and its form can be written as 0. Okay. Now, types of polynomial on the base of number of terms. Okay. So the polynomial with one term is a monomial. Mono यानी सिंगल यानी one term वाली polynomial पॉलिनोमियल इसको बोला जाता है मोनोमियल। एग्जांपल्स 2x minus 5x square minus 7 8x cube. So it can be linear polynomial, it can be quadratic, it can be constant polynomial, it can be cubic polynomial. It doesn't matter whether it is which type of polynomial on the base of degree, but on the base of term, only one term each one has. So these are the examples of monomial, one term polynomial, single term polynomial is monomial. Now polynomial with two terms is a binomial. टू टर्म्स वाले पॉलिनोमियल को बाइनोमियल कहा जाता है। नंबर ऑफ टर्म्स इसे देखा जाता है, दो टर्म्स होने चाहिए। सो एज पर टाइप, एज पर द डिग्री इट कैन बी 2 डिग्री पॉलिनोमियल, 1 डिग्री पॉलिनोमियल, 2 डिग्री पॉलिनोमियल, 3 डिग्री पॉलिनोमियल। ओके, इट कैन बी linear, quadratic or cubic polynomial, it doesn't matter, but with the number of terms on the base of number of terms, this one is a binomial, means only two terms are there. Okay, now polynomial with three terms is trinomial. Okay, so these are the examples. Okay, these are the examples, but most important thing is that n degree polynomial can have at most n plus 1 terms. 3 डिग्री वाली पॉलिनोमियल को ज्यादा से ज्यादा 4 टर्म्स हो सकते हैं। ओके, 3 डिग्री पॉलिनोमियल को 4 टर्म से ज्यादा टर्म नहीं हो सकते। 4 टर्म हो सकता है, 3 टर्म हो सकता है, 2 टर्म हो सकता है या 1 टर्म हो सकता है 4 डिग्री पॉलिनोमियल। ओके, so example is 2 degree polynomial can have at most 3 terms. Okay, so this is all about polynomial. So the important thing about any expression to be a polynomial is that the power in each term must be non-negative number. So then and only then any expression is called a polynomial when power of variable in each term is a non-negative number. Look at it. X raised to minus 2 plus x minus 1 is not a polynomial. Why? See, the power of in first term is negative. So negative powers are not allowed to be a polynomial. This one is not a polynomial. Okay, this one is not a polynomial because x raised to minus 2 is considered as 1 upon x raised to 2. That we have learned in standard 8. Okay, that we have learned in standard 8. So in any term, if the variable is as a denominator, this type of present expression is also not a polynomial. Okay, so when you see any term, in any term, the variable is in a denominator, then it is not a polynomial. Okay, now x raised to 1 by 2, this is not an integer, non-negative integer. Okay, non-negative integer. Okay, it should be non-negative integer. It should also be an integer. ये integer नहीं है, ये fraction number है. So power है वो fraction number नहीं हो सकती. It should be integer rather non-negative integer. Okay, x raised to 1 by 2 plus x minus 3 is not a polynomial because power है fraction. Because x raised to 1 by 2 is considered as square root of x. So square root on x or y or variable, square root or cube root on variable, mind it on variable. See, root 2x plus x square minus 3. Sorry, it has no problem to be a polynomial because square root is there on a number, but square root must not be there on x. Okay, because root x will be x raised to 1 by 2. So this type of expression rather, or this type of expressions are not the polynomial. Keep this thing in mind. Okay. Let us start exercise 2.1. Now question number 1. Which of the following expressions are polynomial in one variable? So we have to verify whether the given is a polynomial or not. Moreover, it is a polynomial in one variable or not. Okay. And which are not. State reasons for your answer. Okay. Now look at it. 4x square minus 3x plus 3. So two things you have to keep in mind. Whether the given is a polynomial. So the condition of any expression being a polynomial is that powers in the variable of each term should be non-negative integer. Look at it. Power in the first term x has 2 power and 2 is a non-negative integer. Here minus 3x, power of x is 1 and 1 is a non-negative integer. 7 is a constant term, so x is also there and the power of x is 0 and 0 is also a non-negative integer. So this one is a, moreover, see only one variable. So this one is a polynomial in one variable. And the reason you can write that in each term the power of variable is a non-negative integer. In each term the power or the exponent power of variable is non-negative integer. Okay. In each term, the power of variable is non-negative integer. Moreover, only one variable is involved in it. Here, y square plus root 2. Okay. Only one variable y is there, and moreover, y. See, the variable is here only, not here. And the power of variable is 2, and 2 is a non-negative integer. So this one is also a polynomial in one variable. Polynomial in one variable because only one variable is here, and the power of variable in each term. Here no variable, so no need to look at it whether the power is non-negative integer or not, or it is x raised to 0, and 0 is a negative integer. So in the same way here, in each term the power of variable is non-negative integer. And look at it. 3 root t plus t root 2. 3 root t plus t root 2. Look at it. Root t is equal to t raised to 1 by 2. So here the power is not an integer, and that is why is not a polynomial in one variable, because the power of variable in the first term is not an integer. So root t is equal to, you know that root t is equal to t raised to 1 by 2. Okay, root t is at t raised to 1 by 2, and 1 by 2 is not an integer. The power of, see, the power in the variable in the first term is not an integer. Here y plus 2 upon y. So 2 by y is equal to 2 into y raised to minus 1. So if you see any variable in the denominator, it has a negative power. So this one is not a polynomial in one variable because the power in the second term of the variable, the power of variable in the second term is not an integer. Rather it's a negative, rather not positive. Okay, it's not non-negative, rather it's a negative, and being the power being negative, this one is not a polynomial in one variable. Okay, here x raised to 10 plus y raised to 3 plus t raised to 50. Look at the powers in of variables are integers, non-negative integers. But look at it, there are 3 variables. So this one is not a polynomial in one variable because 3 variables are involved in it. Okay, so this one is not a polynomial in one variable. Now question number 2. Move to question number 2. Write the coefficients of x square. 1 2 3 4 चारों में x square का coefficient कौन है? So the coefficient of x square, in this case coefficient of x square is equal to x square का coefficient कौन है? 1. कोई भी नंबर यहाँ पे नहीं है तो 1 तो है ही. ओके, और यहाँ पे coefficient of x square is, यहाँ पे क्या होगा? x square का coefficient -1. यहाँ पे coefficient of x square का coefficient क्या है? pi/2. और यहाँ पे x square वाला टर्म ही नहीं, so coefficient of x square is equal to 0. अगर x square वाला टर्म ही नहीं है तो x square का coefficient 0 है. Okay, now give one example each of a binomial of degree 35 and a monomial of degree 100. Okay, binomial of degree 35. Example binomial. Binomial यानी 2 टर्म्स होने चाहिए और डिग्री 35 यानी वेरिएबल की मैक्सिमम पावर 35 होनी चाहिए. सो x raised to 35 तो होना नहीं, उससे ज्यादा डिग्री वाला टर्म नहीं हो सकता. ओके, और बाइनोमियल बनाने के लिए और एक टर्म भी हमें चाहिए, तो हम कुछ भी दे देते हैं, 3 दे दो, या x raised to 35 से कम यानी 35 से कम पावर वाला कोई भी टर्म आप लिख दो चलेगा. There must be 2 terms to make it to be a binomial, and the maximum power of variable must be 35, not more than that. Okay, now monomial of degree 100. Now monomial means a polynomial with one term. Polynomial with one term. Okay, so variable y. Monomial means only one term and degree 100 का मतलब उसको power 100 देंगे. So y raised to 100, अभी coefficient आप कुछ भी लिख सकते हो, -2y raised to 100. This is a monomial means a polynomial with term one term, and 100 degree means the power of variable must be 100. So these are the examples.